talk about a little bit theory. So if you look at this slide, it's somewhere around 35. We're going to talk about like the first 10 slides or so, just to get the theory. Then the other slide will tell us about how we can implement it using, again, Python. So again, I would say the sklearn package also gives us option to use clustering or unsupervised learning. Normally, it will be called a cluster. And the cluster, what type of cluster? We have this. So here we do k-means. So we will say cluster and import k-means from cluster. So we'll see it. So first of all, let's discuss, I think I'm recording now. Yeah, okay. So let's discuss about the whole idea of hierarchy and k-means clustering. So first of all, we define what is a clustering. As we said, in supervised learning, we have the training data. So it's two-step, most of them, two-step, except the k-nearest neighbor. K-nearest neighbor also is a supervised learning. It kind of works like k-means, but k-means is cluster and unsupervised learning. So in supervised learning, we normally build a model first. Then we use the test data to test it. If it's good, then we put it into operation. So the model will do our classification or prediction, if it's regression, etc. Except k nearest neighbor. In k nearest neighbor, we train, and the process of training is the same, is the process of using, making your decision at the same time. So we have to, that's why it's called k nearest neighbor. You have to measure this. It sees a distance measurement again. But again, we will not go detail. Also here, we are not going to go detail, but just to understand the concept. So clustering means grouping of records, observation, or cases into classes of similar objects. So this means if I have two clusters, I will put all the items in one cluster if they are similar. If two items are dissimilar, I'll put them in two different clusters. And normally the best way to measure the similarity or dissimilarity is using a distance, for now using a distance function. For example, like Euclidean distance. So this means if two clusters are similar, their distance from the, let's say if we are using k-means, the centroid, or in general, let's make it in general. Two clusters are similar if the distance between them is closer, or dissimilar if the distance between them is bigger. So a good cluster means we maximize the data objects that are dissimilar. We maximize the distance. And we minimize the distance, or we're looking for minimal distance for data points that are similar. So we say a collection is a record that are similar to one another and still similar to records in order. There is no training, so that's why we don't build a model. There's no target variable like a training data set. The task is not to classify, not to estimate, not to predict. Those are all supervised learning. But we are seeking to segment the entire data set into homogeneous subgroups. So the concept of homogeneous means similar items will be in the same group. The similarity of records within the cluster is maximized. So this is what we're saying. The similarity is maximized, and the similarity to records outside cluster is minimized. So if the similarity is minimized, it means the distance between them will be maximized. Now we can perform we can evaluate the similarity based on the distance. So this is an example of a cluster. Let's say here we have a lifestyle by geography. Maybe like in Manhattan, we have Upper, Bronx, Riverdale, etc. Each area depends. And the lifestyle depends. Yeah, it depends on your income. So that's an example here. We have cluster 01, they are upper crust estates. So maybe this will be the top rich people. Then we have cluster 03, movers and shakers, money and brains. Maybe this will be the educated people. And Bohemian means, but again, Cross theory will be based on some criteria we are going to, if this is income we are using here. Another example here is targeting marketing. A company like Macy have millions of customers, even within New York City alone. If a new product come out and they say they are going to mail the catalog to everybody who buys something Macy, then they are going to spend a lot of a lot of money in their well, nowadays we use the email, but let's say mailing, post office mail. We're going to spend a lot of money on the mailing. Even if it's email still time, a computer can generate them email. So, but what we are trying to say here is that if the product, let's say we have a pregnant woman, then if the product is about newborn babies, then we have to tag. We don't want to give to young men who came and buy things, and so we target customers who buy maybe item related to pregnancy. So it's like Amazon. If I buy a textbook of C++, maybe next time they may advise me to buy Java book because they know if you know C++, it's good to know Java too. Almost likely you are going to your computer science major, so you may study more than one programming language, etc. So that would be like a concept of target marketing. Also, gene expression. Oh, this is used a lot in computational biology. Even microarray data where we put the genes in there, and I say genes, the genes in a microarray like a chip. And that can give us the expression level. So if two genes have the same expression level, we group them together. And this means we say the gene expression level can tell us the function of the gene, or there's a similarity between the two genes since they have the same level of expression. And you also, this is data mining. Yeah, so this is another very good way. So sometimes we may do clustering before we do supervise. It's kind of like sampling the data. So I have a lot of data sets and I want to build a model based on customers who buy things and they are from New York. So I can do clustering based on geographical area. Even there's a training data, but when we are doing unsupervised learning, the training data is not considered. It's considered as another variable or another attribute. So based on the location, we may have all the customers from New York and the rest of the customer from other states in the US. So here we want to know customers who are valuable or whatever. And so the first thing we do now is I'll say segmentation. We divide the data based on location. Then there we can apply our supervised learning, let's say if it's classification. But most of the time, as we all know, clustering is based on what distance measurement. So our data variable, we have to convert it to values. We cannot use the labels or nominal data like tested positive, yes or no, true, false, no. We have to change everything too because the distance measurement is based on, again, values. Unless there are some other algorithm, like k-means, we also have a k-median or median based on the median value or some. Even median value is still a value. I mean, it's not a nominal. This will take us back to statistics, non-parametric. Most of the non-parametric testing, hypothesis testing, they use values based on ordinal, except chi-square that use nominal data because it's based on counting. Yeah, so that's few example here. Let's move on. Now, that's what we said earlier. With clustering, we always have to recode the categorical variables. Now, because we measure this, we are using the distance. In this case, this general concept, because we are using distance to measure the similarity, it's a good idea to standardize or normalize the value because I don't want to have one variable is 10, then another variable is 100,000 or even 1 million. Wow, 10 and 1 million. And 1 million will overwhelm 10. It will make no difference. So in this case, I'm using 10 and 1 million because I can find a log base 10 very quick. So I'll normalize this data using the log base 10. And this means 10 will be 1 million will be 6 because 6 zeros. So 1 and 6, yeah, it's good than 10 and 1, 10 and 1 million, where 10 and 1 million is totally too much difference. Yeah. So this, the need to determine how to do recording the categorical variable, standardize or normalize the numerical variables. And also, I think this is one of the most important. How many clusters we expect to uncover? Good news, in some of the algorithms, like the k-means we'll go through to see how we use it in Python also, is that we have to specify the number. K means the number of clusters we want. So we have to be careful. I think this is based on experience. They say K is 2, 3, 4, back to 2, 3, and see which one. But we have some algorithms. For example, the self-organizing map, which is cohorted algorithm. It's an idea, it's a special neural network. So neural networking, we have the one for unsupervised learning clustering also, which is the self-organizing map. It's a good one because we don't need to specify the number of clusters. The algorithm will choose the number of clusters for us. So we say that algorithm is normally used for high dimensional data like image segmentation. No. Yeah. Sorry, I need to drink some water. That's why interruption. So those are the, and also the measure of similar. So here, this is very straightforward because we already have majority of the algorithm like K-means who use the Euclidean distance to find the distance between each point and the centroid. Then we also have another city block, Minkowski, etc. These are all distance measurements we can use. So that's the record categorical value. This given example. And also to normalize, okay, so normalize also we can use the mean mass. This is used a lot in statistics. Actually, both of them is score, so it's used to normalize data. So I have a large, the variation of the data is too large or whatever it is. All you need, just find the standard deviation, find the mean, subtract the mean from each value, and divide it by the standard deviation. That will give us a new value for each value. And because of the mean standard deviation, the data will be normalized. Or we can use the concept of mean mass, which means you subtract the value from the minimum value among all the value, then you divide by the range. So the difference of the maximum and the minimum value. And that will give you a new value also. So sometimes we use the mean mass, so those are the most, I would say, starting point of normalizing data. Then we have some more advanced concepts. So the goal of cluster, as we said earlier, is what we have here. Here we have 3 clusters. We want to make sure that all the items in each cluster should be similar. All the items in different clusters should be dissimilar to each other. And it will be based on the distance measurement here. So between cluster variation, we want it very big. That's the plain line. Then we can see within cluster variation, the distance is very small. Normally, the center of each cluster is called a centroid. And something like K means we have to update the centroid and update by itself. Oh, hold on one second. Any question up to here? Okay, so we're going to finish the theory around here. So this is the concept of hierarchical clustering method. So as we said, there are so many different. We also have the agglomerative method, divisive method. Yeah, so divisive method, actually the name already explained. Dividing. So divisive method said we begin with all records as one big cluster, all the record one cluster. Then we start to split off the most dissimilar from it. So we divide in until If we set that we need 4 clusters, then when we reach 4, it will stop. Or until we make sure there's no dissimilar records in the same cluster. So the name divisive or divide. So we start the whole thing as a 1. Now with agglomerative, now we're going opposite now. We initialize each record to be a tiny cluster of itself. Then we start to combine based on similarity. So if we see 2 records are let's say we use the distance measurement. So if they are very close to each other, we combine them. So agglomerative start with each one unit. Each one data as a cluster. Then we start to come. Divisive, everything is one cluster. Then we start to split. So we can generate something called the tree-like cluster structure, which is the then program is created through recursively combine or dividing the records and using this. And I think we will see the diagram around there. We are going to stop. So now, to determine the distance between clusters, we have 3 methods that we can use. First one is called a single linkage, complete linkage, and average linkage. So single linkage normally will be based on nearest neighbor, which means we are looking for the minimal distance between the records. Then we normally to form something called a long slender clusters. Then the complete linkage, you got opposite now, far away or the furthest neighbors. So the goal is to maximize the distance between the records. Then, of course, the name here means average. So based on average distance between the records. This normally will reduce the dependency on extreme values. Very small, very big value. Yeah. So also outline data can have effect on clustering also. Let's wait for a few seconds if any question. Okay, let's keep going then. So here we have some examples given. I don't know whether we should stop around here. I think we have got enough knowledge. So let's hold on to here. Let's do the Python section first. Or if any, actually, let's do this example, how the whole single and so single linkage agglomerative. This is like a toy example. So here, very rare that you may have a data set arranged like this. Well, let's assume this is how it's arranged. So we have a data set 2, 5, 9, 15, 16, 18, 25, 33, 33, 45. And based on the similarity, we are going to combine them. So this is like starting, it's the concept of agglomerative. I think we saw it. We are zooming agglomerative, initialize each observation to a tiny cluster of its own. So that's what we're doing here now. So we have clusters 2, 5, 9. So if you see 2 similar, we combine them. The similarity is based on the distance, and we kind of saying that the values are something like that. So step 0, assign each record to its own cluster. So we finish that. Step 2, combine the clusters. Oh yeah, 33, they are very similar too much, the same value. So the distance, if we are using as a distance measure, that means the distance is 0, is the same. So that's the first combination. The second, we don't have no more zeros. Ones, oh yeah, we have ones here. So 15 and 16, we combine it, nearest neighbor. The next, we have 2s, 3s, 4s. Okay, they said this, 2, 5, 3. We don't have no 2s. So we finish. 2, 5 is combined, 9 is not yet, 15, 16 combined, 18 not yet, 25 not yet, 33, 33, 45 not yet. So we go to the next line here. We can see how simple they are. So here now I have 2, 5. The next 5 to 9 is 4. 9 to 15, oh no, too big, 6. So that will not work. Oh no, yeah, no, it won't work, sorry. So that's why they join the 9 here. And of course, if 9 doesn't work for 15, it will not work for 33 or 45. That's very far away. So the nearest neighbor again, we are using a single linkage, nearest. So 2, 5, 18. Yeah, 18 is good. 16, 18. 18, 25, too much. If 25 is not good, 33, 45 will not be good. So 18 join here. So you see, we're getting close. Now we have 259, 15, 16, 18. We are joining here, 9, 15. The difference is 6. Yeah. Let's see, 18 to 25. The difference is 7. Oh, okay. So that's why we join it here. We didn't join to this side. Then we keep going till the end. Again, I don't want to, because of time. I'll wait for a few seconds if any question. Also, the steps are told here. So we can see what we are saying. They combine 2 and 5, 259, 259 with 15, 16, 18, etc. all the way down. Let's wait for a few seconds if it's okay. Okay, now let's see the next example, which is the complete linkage clustering. We say complete is based on far, but still you can see in the beginning, we still use assign each record, combine the clusters value to 3. Where you will see the difference will be from here. So you see the 259 is okay. By here, we join 40, around here, 33, 25. Then 45 join here. But when you look here, 45 didn't join, it joined at the end. So we start to do the farthest away. And then 259 here, 25 go to the same thing here. We can see 25 didn't go here, but rather go here. Yeah, I mean, it go to the right, didn't go left. Farthest away. That's the whole concept here. 25 to 33. I think the difference is 8. Yeah, 8. It's 18 to 25. The difference is 7. But it didn't go 7, it go to 8, etc. And this is why I'm going to end it. The slides here didn't give us example for the average, because the average is a lot. You have to find the average also is a long kind of a little bit more process. So most common is single complete linkage. Now, before actually, yeah, so we have the algorithm here for the k-means clustering. So this is plain English, how the algorithm work. As we said, first we find the value of k, how many clusters we want. Randomly assign the k records to initial centers. So if it's 3, randomly we create 3 clusters, we put any data anywhere, it doesn't matter. No, matter. But again, we are going to do what we call learning process. So we find the center of each cluster. Then we measure the data to the centroid, data to centroid. Then if there's any update we have to do, we do. We use the Euclidean distance for that. So you can see the step here. Randomly assign k records to initial clusters. Now for each record, find the nearest center, where the nearest is usually the nearest center we call the centroid. So for each of them, find the cluster centroid. Then repeat step 3 to 5 until convergence or termination. Convergence means we will keep changing the centroid. We put in the points. We measure each point to the centroid. The shortest we put it in that centroid. The centroid is the center of that cluster. We put. Then in some stage, the centroid doesn't change no more. No more conversion. Or we set some condition to terminate it. Then that will be the end of it. So that's all how the algorithm works. Here we have example how we can do it manually. But I don't want this because I'm looking at the time also. I'll hold on the slides here. If we have to, then we come back and do it. Next, I want us to see how we do this in Python. I think that's our main that's our main goal here. Okay, so in this section of the slide, they also explain to us what is a clustering again. So I'm going to skip all these sections. As we said earlier, no target variable, grouping of records into classes of similar objects, etc. Examples can be in business research, including targeting, accounting, gene expression. And this is how example may look like. And now we're going to focus on the k-means. So first step, as the user, how many clusters k the data set should be partitioned into. Second, we randomly assign K records to be the initial cluster center location. Now, for each record, find the nearest cluster center. So it's almost the same algorithm we saw in the previous slide. And then we get K clusters if it's 3, C1, C2, C3. Then for each cluster, find the cluster center, the center of the clusters. If it's 3 centers. And update the location of each cluster center to the new value of the centroid. Repeat this step until no more convergence. So let's look how the whole thing works here for the game. So normally, as we said earlier, we have sklearn cluster. Okay, let's skip all this. The application of k-means. If we need to come back, we will come back here. I want okay, this is the only part I want us to look. Then maybe we'll go back against 4. No, we have time, see? Sometimes I always think the class finish at 4. It's 4 o'clock now. 30 minutes a lot. Okay, so so we talk about the algorithm here. So the application of k-means clustering, they say very important to not include the target variable. Or you can include the target variable, but we see it as ordinary, it's another variable, ordinary variable. Unless after you segment, you can use it to get a sample of a data based on some criteria. Then from there, it's a target variable now if you want to use it for supervised learning job task. So for clustering, or in this case, k-means, so clustering. So no target variable. Also, it's very important to standardize. Very important. I think we said that already. We don't want one value to overwhelm the other. So then k-means require analysis to specify the desired number of clusters. So for example, here given, I have 2 clusters. So cluster 1 has a mean sugar content. Again, here we don't have the data set, but when they do the work, they came up, cluster 1 have a mean sugar content of 0.96 standard deviation above the mean sugar content. And cluster 1's mean alcohol content is 0.17 standard deviation below the mean. And also we have cluster 2 has a mean sugar content of 0.62 standard deviations below the overall mean, and alcohol content at 4.49 standard deviation. So based on this sugar and alcohol content, etc., we were able to say that cluster 1 contains sweet wines because you have a high sugar but low alcohol. Cluster 2 contains dry wines because you have low sugar but high alcohol. And this is the results. Again, we don't have the data. This is just an example to tell us the idea. Then we can see our variable for sugar and alcohol levels. And also here, the training set, the test, training test. Again, this will be difficult to understand just to get the idea of the values, but we don't have the data here. So this is how to perform k-means cluster using Python. We can say the steps are the same as supervised learning. First, we need our data, but before we load the data, we make sure the data is screened already. And that's what we are doing here. You can see here, we don't have no Y, only X. So here we are using, okay, so that's the example here. And the example result they gave us, that's the data we are using here. So we have a wine train data set. We just want to use only 2 columns in the data set, alcohol and sugar. So based on the level of alcohol and sugar, we are going to cluster whether it's a sweet or not sweet one. So first thing we do, we get our data and it's okay. Let's see if we should standardize the value. Now it depends. You look at the values, you learn. I think that's the first thing we do. We have to understand our data. Look if the data is already normalized or well prepared. Not otherwise, they say we can standardize our data using the z-score transformation and save the result. Then from there, the data is ready for clustering. So we import the sklearn.cluster from sklearn.cluster, which is the machine learning package sklearn, the clustering section. We import the k-means because that's what we are doing here. So here we use the k-means. We have to specify the number of clusters. So we say it's 2. We have to fit it into our data set, X. And here we put Z that if it's normalized. Let's say we didn't put a step of normalizing here, but let's say this is the data. So here we say the k-means now we set up the k-means algorithm for us. The number of clusters is 2. We specify the 2 clusters. Then it will save the cluster membership as its own variable. So here we name it a cluster. After we get a k-means 001, we assign dot labels, assign to clusters. Let me wait for few seconds if it's okay. So I'll say for simplicity here, we can isolate the predictor variables and save them as X. That's it. And that's what we did here. If you like, we don't need to use the XZ. And so we have the wine train, alcohol, and sugar assigned to X again. First step. Of course, first step we import the package we want. So once we have our predictor variables, we can standardize them using the z-score transformation. Again, here we don't have it here, but we have a function. Of course, we have the z-score function. The z-score function also is named z, everything lowercase z-score, and the argument of the z-score will be the X here in this because we ought to start. But it comes from the package of the stats. If you remember last week or a few weeks ago. So I have to import that one too. So stacks dot z-score X. Then we set a column also if we want to. Actually, we can use the pandas data frame. PD. Excuse me, if we import the pandas, we can just say PD dot data frame, the argument start dot z-score X. Excuse me, God. Let me drink water, please. Yeah, so we can use the pandas also here with the data frame. Then we set the z-score. If we have the, so we just skip that section. So we will assign it to XZ. That's why we say XZ. Then we're good to go. As we said, we specify the number of clusters to be 2, which is right here. And then let's wait for a few seconds if any question. So as we said earlier, also the k-means command will set up the parameters of the k-means algorithm. In our case, again, as we can see it on the screen, and clusters equal to 2, we specify that we have 2 clusters. The fit command, we use it many times in many algorithms and machine learning packages. So the fit command will run the specified k-means algorithm on our data with the input of X, Z, again, z-score of the X value. Given that the data, again, data set we want to cluster. Then in this case, again, we name it k-means, again, 01, if it's okay. Now to investigate the clustering result, now we need to save the cluster membership as its own variable. So that's where we have the k-means 01 dot labels underscore, we assign it to cluster, and that save the cluster membership at its own variable. Then possible now we can separate. So the cluster membership information is contained under the labels underscore, within the k-means 01 result. Now, once we have cluster membership information, now we can separate the records into two groups based on the cluster membership. So you can see we have the xz.log cluster is equal to 0. This is it here. Then second, again, we specify two clusters. xz.log cluster is 1. So we have 0 and 1. So the results are two data sets, one for cluster 1 and another for cluster 2. Finally, we can compute the sum statistics if we want to of the two clusters using the describe command. I think we used that also before, just to know the values, understand the values in each. So we can do summary statistics on that. So again, the describe command print the various statistics for the variables in each cluster. For example, mean, standard deviation, mass, mean, etc. Now, the last section, as we said over there, to validate, run the k-means clustering on a test data. That's optional. That's optional, but to validate. So it's not like we are creating a model. Here is to evaluate it. So it's like evaluating it. So if you have two data sets similar, we can do that. So let's wait for a few seconds if any question. So that will be the conclusion. Now let's call the attendance then. If let's see our time. Okay, okay, time to go now. So let's start the attendance now, if no question. Before I stop the recording. I guess I chose clustering because in the previous sections we have done a lot of supervised learning already. So we do like decision tree. I'm not sure we didn't do neural networking. We do random forest, etc. So again, it's very nicely we move to clustering. Next week, if possible, if we have to do association or any other algorithm. By next week, we don't have no time. We still have a natural language process to follow. And we still have let me look at the syllabus, ethics. So if no question, I'm going to turn off. As I said, recording, I don't like to put student's name here. If no question, let me stop recording, then we look at the syllabus.